So, hello. How are you doing so far in the conference? Yeah, kind of getting till the end of the day. So I'm Osvaldas Grigas. I want to share some of my experience in writing developer tests. So I'm not going to talk about end-to-end front-end tests, mostly back-end stuff, because that's what my experience is most of the time. Although I am kind of a full-stack developer, sort of. And not really applicable to data engineering because those guys never know what they are expecting from the system, so they can't write reasonable tests. Sorry. Yeah, and this is kind of a passion topic for me because I've been doing software development for about 16 years and my style of testing has evolved, and in recent years it has taken a weird path, which was weird generally for me. And so I wanted to share some of my insights of why it happened, I think, and it may be a little bit surprising, especially for people who have heard me talk before about things like unit testing and mocking and test-driven development. So I'm not going to shock you, but it's just because I find it interesting, maybe you will find it too. Yeah, so I will go through introduction of myself very quickly, through what I work for, and then I will talk about evolution of my own testing style over time. Then I will take case studies, and this will probably be the largest part of the talk. I will take like 4 case studies from different companies I worked for before, and how I approach testing, and what worked and what didn't work well, and why. Some of the things I learned on the way, and eventually I will take the current preferred style and the pros and cons of how you can do that and what it entails. All right, so I am a software developer first and foremost. I have been a little bit in management positions, a little bit in data science, and a little bit in testing, but mostly software development. These are the languages I have used in production. My core competences is in JVM stack, also in .NET. I've done PHP and even Visual Basic, so I'm not proud of that moment of my life, but it paid the bill. Yeah, and I worked on web APIs and enterprise integration and a little DevOps, a little bit data engineering, low latency stuff, single page applications, a lot of enterprise integration. Yeah, and in the domain of insurance, statistics, advertising, financial services, and so on. So it's varied. It's mostly to do with enterprise software, although not exclusively. So just to know where my background is. And I also did a lot of workshops and mentoring new people and lecturing. So I consider myself kind of a teacher. Well, a teacher from a small T, you might say. One of the workshops I do is Code Retreat. Has anyone been to a Code Retreat before? Yeah, whoa, quite a few people. There's one coming this Saturday. Look it up, Code Retreat Vilnius. Last time I checked, there are 3 places remaining, although it may be not true by this point. So it's a shameless plug, but what you can't do anything about it, right? So then recently I joined Platform Lunar, and this is what our Vilnius office looks like. It's pretty cool, like a moon base. That's actually why I joined. I really like this tapestry. And then what we do is custom ad tech and martech solutions, which is jargon for advertising and marketing technology. We have 2 offices in Vilnius and in Hamburg. And that's all I'm going to say about the business, because that's really not the point of this talk, because these principles apply across the board. Right. Our technical stack, if you're interested, is in front end we use React and GraphQL. Then in backend Java, some Groovy, Spring Boot, Netflix open source stack. So kind of standard stuff. This is mostly where I spend my time, back and front end. And on the data engineering, we have Scala, Python, Spark, Hive, Jupyter Notebook. We terraform our stuff with Terraform, and we use Ansible. And we deploy Docker containers, run them on Amazon. We use extensive use of AWS stack. So that's it for my introduction. Now I'm going to use this terminology. I'm going to define system under test, and that's the thing you are testing. So whatever you are carving out in your test and that depends on what strategy you use. It could be a single class, it could be an entire microservice or a set of microservices, including or not including the database. That's your system under test. Everything else is isolated into interactions, preconditions, and postconditions. And the test client, all it does is sets up preconditions and then sends messages and expects some data. So your entire code under test can always be described by incoming data and outgoing data. That's all you need to know about system under test. I try very hard not to use these terms like unit tests, integration tests, and E2E tests. Several reasons. One is because every developer has a slightly different understanding of what they mean. So when I say a unit test, some may imagine it's a single class test, although you can test multiple classes in a unit test, right? Where integration test could be several classes as well, but it could be the entire system, or it can be integration to a third-party system. And end-to-end, does it include the front end? No. Does it include the database? Maybe. So I think these terms are mostly misleading, so I will avoid them. I will just say you can always define them by carving out some kind of isolated part of a system, and that's what we're testing, not trying to find a name for it. Okay, so how did my style evolve? And that's really all I can talk about, my own experience. Starting from no testing, those were dark times. I did manual testing. Then I discovered you can actually automate tests, and then the level of integration was pretty high. So when I started testing, it was kind of random integration. There was no rhyme or reason to the kind of components I would integrate before testing them. Usually it was whatever worked for that particular application or code base I was working in. So whatever framework we were using for testing, it all, I wasn't picky about it. After some time, I discovered that actually the way to go is unit testing single classes, and everything else needs to be mocked out. So I discovered J.B. Rainsberger and Nat Price and Steve Freeman and their teachings, and I went full mock pathway. You could call it the London style of test-driven development. This didn't work well, at least not for a long time. And then I started integrated things. So I said, okay, sometimes you can test more than one class at a time. And it actually makes sense if they are cohesive, right? If they change together. And then I started to integrate it a little bit more. So I started testing vertical slices, which is the whole, say, service from its inputs to the outputs, maybe to the database, but did not include the system boundary. Then I also included system boundary and started testing the process as a whole, isolated from its outside inputs and outputs. And eventually, I started integrating it with external dependencies like databases and queues. And this is the weird part which I did not expect. Why did I go that way? And I'm saying this is preferred style. So I will go through the steps with case studies. I'm just saying it's not the only kind of tests I write. It's just the ones I start with, and then if I feel the need for end-to-end or isolated testing, I write those as well. It's just that I find most value out of these. Okay. Everybody knows Gene Rainsberger? Who knows J.B. Rainsberger? Yeah, well, not everybody. No. To say the least, you should look him up. He's a very interesting guy. He's like the enemy of integrated tests. He has written and talked about the scam of integrated tests, so to speak. And he says that these are unreliable, self-replicating time wasters. And actually, he calls them, let me see if I can read it. It causes endless pain and suffering, right? So this may flag a few red flags in your heads when I'm talking about integration. And also, as I discovered mock objects to be precise, this is the original paper about mock objects, written by Steve Freeman and others, which eventually those ideas grew into a book called Growing Object-Oriented Software, Guided by Tests, a great book. And the principle is like that. So they say most non-trivial code is difficult to test in isolation, which is true. And you need to make sure that you test one feature at a time, which makes sense, right? And I bought it, and I spent the rest of my large part of career writing tests like this. So this is one of the earlier enterprise software solutions I worked for. I don't even know which one it is, because they were all the same, essentially. They all had a user controller and a user service and a user repository, or a user data access object. No one could ever explain the difference between the two. And the database. And the way I would write tests is like this. I would say, okay, my test client would test user controller, and it would mock out the service. It would stub results and would expect some invocations, if that makes sense. Then I would go a level deeper, the layered architecture, and test that with mocking the repository, and so on and so forth. Now, if you read the original paper about mock objects, it says that our experience is that developing unit tests with mock objects leads to stronger tests and to better structure. Now, I'm genuinely interested. What is your experience? So how many people have this experience that using mock objects leads them to stronger tests and better structure? Okay. 10-ish, 15 hands. Who have the opposite experience? Okay, I would say about the same number. Right, and the rest of you just don't care, which is fine. Right, this is interesting because it's such a powerful technique and it's so strong, so talked about, and yet people have these different experiences. For some, it makes the structure of the code better. For some, it makes it worse. How can that be? And then, well, maybe I will stick to it a little bit longer. I think the problem is that when you're mocking things out and you expect it to improve your design, because that was one of the points of mocking. You want to improve the internal interactions between your components in the code and extract the messages between them to make them more relevant, more business-centric. The problem is, if you already are an experienced designer, software designer, and you know what to look for, then mock objects will give you hints as to how to improve your design, right? But it's not the tests that push you towards a better design. Well, they kind of do, but you know what decisions to take, right? So you know how to improve it. If you don't know how to improve the code, the mock objects will simply reinforce whatever crappy design you already have, right? So it comes with a double-ended sword. What's the metaphor? Something like that. Okay, and then there's the problem with system boundaries. So whenever you leave the system, like you want to call a database, I always left a kind of, dirty when I did that. So why can't I unit test the database? Why can't I isolate it? Why do I have to write an actual integration with some kind of in-memory database when I write my tests? But then I read an article by G.B. Rensberger. Not then, actually, I read it now, but it would have been applicable back then. And he says, the same guy which says integrate tests are a scam, he says, when he's writing glue code, in this example, it's building entity framework link query from user inputs, it is uncouplable from the database. So glue, of course, he meant to say undecouplable from the database, because you can't decouple it from the database. It makes no sense, because all your unit test would be testing is the way you implemented your method, not the actual feature you are trying to implement. And that's a good point. There's a lot of glue code we write in our software. And glue code happens each time we are at the system boundary, and each time we try to integrate to a library or a framework. So all of that is glue code. It does not have any business rules. And the more I work in these domains, the more I find that my services are composed mostly of glue code and a little bit of domain logic. If that's good or bad, that's another discussion, but that's the state of the art right now that I see. Not just mine code, of course, others I speak to. And so the other case study, I tried to learn from it. I said, okay, I don't really have to mock out everything, integrating things is not always evil. And so I worked for a system. It was a banking core, and it used CQRS and event sourcing as the core architectural patterns. And it works something like this. Well, you probably know this, but I will present it very quickly. So there's a client. He sends a command to a command dispatcher, which then dispatches the command to command handlers, which are handled to aggregate routes, which kind of aggregate a bunch of entities. There's the domain logic. And then you have domain services, factories, and a bunch of other stuff. They eventually generate events. Those events are stored to event store. From that event store, you can rehydrate back your aggregate routes. So you have state loader, which loads events and builds the aggregate state out of them. That's the event sourcing part. Eventually, data flows further, and an event dispatcher moves it to some event projectors, which call projection repositories and serialize them to some kind of projection database, which in our case was MongoDB. From there, the projections flow to a deserializer into query services, which are queried by the same client, and he gets the view data. That's the read model. The important part here is where do you draw the boundary to test against, right? So whenever you have any kind of code base and you want to test it, the first question you ask, okay, where's my boundary? Do I test every single class? Do I test command dispatchers together with command handlers? Do I test just the aggregate routes, the business logic? So we found that the most cost-effective way of writing tests in this kind of system is to use the messages as inputs and outputs. So whenever you see those orange arrows, those are the messages. Commands are messages, events are messages, queries and view data, and maybe projections, they could be called messages. So that's what we did. We said, okay, so our test client will give preconditions in terms of past events. So it will say, given something has happened, those are the past events, they will go to state loader. When I issue a command, that's my action, I expect new events. That's the expectation, the assertion part. And that's it. Whatever happens in between, I don't care. I don't care if I used command handlers or some other stuff, if I have domain services or factories, how do I build my aggregate routes, I don't care. All I care about is these are the input events and commands, and those are the output events. And I define my whole use cases in terms of those. And this actually, even though it's highly integrated, it turned out to be very robust and very fast actually tests. And the nice part about it is that we could refactor any way we liked, so long as the messages remain the same. Okay. So I don't know if J.B. Rainsberger would approve of this kind of testing. I think not, although I should talk to him about it. I'm not sure, but the fact that it worked nicely. And on the other side, same thing, I won't spend too much time on it. So given some events as a precondition, we expect certain data from query services when we issue a certain query. That's it. We don't even test the database. So our projection database, we used just in-memory Mongo version, which is Fongo, and we ignored all implementation details. So we're missing something. We exclude the system boundary. So what happens when you don't test how your messages, and by messages I mean whatever comes in and comes out of your tests, are being serialized or deserialized, right? Well, let's see an actual example. That's not from that project, that's from some, whatever, I just made it up. But let's say we test a vertical slice of a system. So we have a controller, and we set up the controller with whatever dependencies it needs. We have an in-memory database, we insert some data into some table, and we say, okay, I'm activating a user, that's a controller action, that's the user ID, the locale, if we need it, and I expect this user to have a status of active when I fetch it. That's it. So that's a kind of vertical slice test through the system. Now, what is it actually testing? By the way, this is Groovy code. and Groovy is in the dynamic language. And one thing I suggest strongly is to use dynamic language to test your code. It doesn't matter if what you're testing is a static language, or it's an entire system. Dynamic languages give you a lot of leverage as to the inputs and outputs. So try it if you haven't yet. Well, what are we testing? We're testing the class structure. So this is a very simple system, right? Just use a controller, uses repository. But in any kind of realistic system, there would be a whole deep nesting of dependencies here. And we would all be hard coding it into the test. We're also testing that the persistent model is like that. So we're using a user table. Inside the table, there's a user entity with certain attributes. We also want to encode in our test that the way to activate a user is through a certain method with a certain signature. And if you're using anything like a MVC framework or so, you will know that there are many ways to map an incoming request to a method with parameters. And we're hard-coding one particular method for some reason. And we're also testing a view model. Not the JSON or something, but just our representation in objects of the view model. All of these details are not important. So all of these details are really implementation details. We should be able to change them without breaking our test. What really matters is what we're not testing. So what we're not testing is, have we configured our entities correctly? Do they match the database schema? Also, what is the request method we're using? What is the path of the request? Do we have set up the routing correctly? What's the response status code? When we activate a user, does it return 200 or 204? I don't know. What does the client expect? Also, how do we serialize the response? Has anyone had any bugs with serialization which were only to do with configuration? Like I certainly have, you know. Some of them were really bizarre. Like I was including a library into my Java class path, and I didn't do anything with it. It just was there. The simple act of including a library in the class path broke all of our HTTP outgoing messages. Broke because they changed the serialization from JSON to XML. Just like that. Well, that's your framework magic. You have a question? Oh, you. Okay. Yeah. I feel you. So yeah, I mean, all our tests were passing because we're not really testing from the outside system boundary. We're testing just the object model things, which is always consistent. Another very interesting bug was, well, we were depending on another service which broke all of its clients by changing JSON serialization configuration to use Pascal case instead of camel case. You know, and again, all tests were passing because serialization was not being tested. So all of these things amount to something. Even more so when you're using microservices. Again, I don't like this word like many speakers. I think a more reasonable word would be mini-services. So let's call them mini-services because they're not that small, usually. So the smaller your service gets, the more of a proportion of that service is occupied by frameworks, configuration, and glue code. So remember, glue code is your code which you're using to integrate to libraries, frameworks, and input-output like system boundary. Configuration is whatever you can't test with a unit test. So things like annotation on Java classes, attributes on .NET classes, configuration files, and so on. And frameworks, we all use them, love them and hate them, right? But we use them anyway. And frameworks make it notoriously hard to unit test stuff. Even though you might say, okay, frameworks are already tested, so we don't need to test them again. Yeah, they are tested, but they are tested in a generic case. They're not tested in a particular kind of configuration in which it's integrated to your code base, right? So you still need to test it, and there are very nasty bugs lurking in the integration and glue code part. And actually, it's more than the business rules. So business rules are fine. isolated unit tests are fine for them. But everything else, the question is, where do you want to concentrate your testing efforts? What's the most bang for the buck you get? It's not the unit test. Okay, another short case study. It was, again, microservices architecture. We are using etcd as the database. This was the mobile payment system. You might have heard of it. It's the Moku mobile payments. So it's the mobile backend for that system, not the whole system. And let's take payment service as an example. So our client would be sending HTTP request. It would be handled by a bunch of classes which I really don't care about what they are. Some of them would call the database, in this case etcd. Some of them would call other services, the HTTP, and some of them would call third-party APIs. Now, and eventually we got the response. Now, when we want to test this thing, what do? We treat the service as a complete black box. So our test client just sends a request to a flying spaghetti monster who is controlling all the knobs. We don't know what's inside, right? It might as well be a flying spaghetti monster. And expects a certain response. That's it. And all the dependencies need to be mocked, of course. So instead of the database, etcd, and all the APIs, we're using mocks, and we were using wiremock. Anyone using wiremock library or server? Yeah, it's quite powerful. And in wiremock, you can see, okay, I expect that certain HTTP requests were made during this invocation of a system under test. And if they were made, please respond with these stub responses. So it's just like object-oriented code, although not at the object level, at the service level. The idea is the same. And well, it worked to a certain extent, right? So it was fine. The fine thing was that I could define the service entirely in terms of the incoming and outgoing messages, which is cool. That's the thing you want to encode, so that's the thing that matters. If a service breaks, it means you just broke one of your clients, or you broke one of your outgoing integrations. So a test would only break, in this case, if you actually broke something important, and not that you renamed the method, or renamed some kind of restructured things inside of the service. One problem is that we also mocked the database in this way. It's good enough that etcd database, if you haven't used it, it has an HTTP API, a RESTful API. So you can mock it this way. It's possible. It's a little ugly. In general, mocking the database does not work because the protocol is too fine-grained. For example, in the case of a relational database, you can mock out SQL queries. Okay, you can do that. You can expect certain queries to be sent out. The problem is these are very fine-grained, very generic. There's a lot of ways that you can bring database to a certain state. And you are only expecting one of the possible ways that this interaction will happen. So these are implementation details. They should not break your test. Binary protocols are also hard to replicate, as in the case of AeroSpike. I tried to mock out AeroSpike binary protocol. It didn't work. I eventually just forgot about it. Also, you have many relevant details in the database integration protocol, details which have to do with the protocol itself and not the business message you are trying to send. One nasty part about it is that it may change when you upgrade the driver or when you upgrade the database itself. And we had this problem with etcd. So we had hundreds of tests, or thousands maybe, of tests which were testing against a particular etcd protocol version. And when the version changed, we couldn't go through all those thousands of tests and change them to match the new protocol version, right? You see the problem. The protocol itself was an implementation detail which should never have been put into our tests, but we did it anyway. Yeah, and actually this matches perfectly to one of the rules in the book I already mentioned, the Goose book by Steve Freeman and Nat Price, which is only mock types that you own. You may have heard this rule. It just says if you are owning a certain protocol, which means that's a protocol of your own service you're calling, or the other object you can change if you want to, then you're allowed to mock it. If this thing you're mocking is implemented by a third party, and there's no close collaboration with that third party that you can influence the protocol, you can't mock it. The whole point of mocking is to enforce a better integration, right? So enforce a better interaction between the systems to improve the protocol itself. You can't improve it if it's a database, which you don't own. Which brings me to Platform Lunar again, and this is like the final case study. In this case, it was also a microservice architecture. Actually, when I joined Platform Lunar, I was surprised to discover that the very experienced people who work there matched my testing preferences, so to speak. So they have also evolved in a similar fashion to this kind of testing style, which I find interesting. So maybe there's something to it. Right, so we test the service, a microservice, mini-service, whatever, which looks like this. I'm going to skip the dependencies. So it uses a database, which is Postgres in this case, and a message queue, which is RabbitMQ, via AMQP protocol, and the user service. So, right, one thing you might be tempted to do is, as I did before, to represent all of a service in terms of incoming and outgoing messages. So you might say, okay, let's mock out AMQP and HTTP and the SQL and data sets. Again, I mentioned why mocking those binary and database protocols is not a very good idea. So the only real thing we want to mock is the interface we own. In this case, this is our other microservice. So we are going to mock this one, and we're not going to mock the other two. What are we going to do? We're going to just run the system with integration to Postgres, like the real Postgres. Of course, it's not real, because it's not production data. It's just a Postgres in a Docker container, the image we just pulled from the internet, but it runs the same version of Postgres. We can make sure it's the same version. And RabbitMQ as well, Docker image, which runs the same version of RabbitMQ which we use in production. So we have a high degree of confidence that if the test passes, it will probably work in production. And the thing we mock is user service. So same thing, test client sends a request, expects a response. If we need to set up precondition, what's precondition? Well, some data in the database. So usually what you will do, I want there to be a campaign in a database with certain properties so that when I fetch it, I expect certain result, right? So that's the precondition. So how do we set it up? We can't touch the database. That's an implementation detail. What do? We send more requests. So the preconditions are done in terms of other HTTP requests. So we can say, I create a database as a precondition. I put some data into it via HTTP API, and then I call it as a matter of test. Also, I expect certain invocations to be made to other services, and if some message is being sent to MessageMQ, I will simply subscribe to it. So our test client is a subscriber to RabbitMQ, and he listens that certain topics or certain exchanges have certain messages, which is part of the interaction. Okay, so far so good. But if you just want to ask anything, just jump right in, shout, yeah. Yeah, good point. It's our service that it's developed inside our company, but it's owned by another team. Well, it is what is us, right? It's our because it's the same company. The thing is, we can influence its contract. So if we're expecting certain interactions with that service, and in the test you will see very quickly, because it's mocking, that those interactions are very chatty, for example, or they expect too many details, it's hard to set up. So you will apply design pressure to this interaction, and you will say to that other team, you know what, guys? Actually, instead of 3 requests, why not we send 1 request? Please change your interface. And so they will change the contract. And this kind of pressure is what's expected when you're using mocks. It works in object level. It also works at service level. If this were a third-party API, there's no way we're going to influence them. So if their protocol sucks, it will be very hard to unit test and to set up and so on. Yeah.
So in this case, since you don't touch the database, for example, verify what the status after your interaction, right?
Yes, we don't even know that there's a database.
So, for example, if you write a service and you use, for example, the memory map or data storage, you forget it. Your test passes because you put the data through the HTTP API, right?
Yes.
But you will get a real analysis required when you use it in production and you restart the service because all the data is lost.
Well, if you restart the service.
Yes, the question is, how do you know that your storage is really the real storage, not some kind of memory leftover from previous iteration?
Okay, so that's my troll. I promised he would be trolling me throughout the talk. It's a good question. Okay, so the only things that matter in any kind of testing is what you care about as an end result, right? So is there any kind of side effect which you can verify, which would say, okay, if this happened, or if this data is here, my test has passed. If your service is writing to an in-memory mapped file or whatever, I don't really care, and nobody is reading from that file, then why is it even there? Okay, so if somebody is reading from that file, then that part which is the thing that's reading needs to be tested. It needs to be part of a test. Also, it could be that it's writing to an in-memory mapped file, but it's also reading from it, and there's an API here which I could invoke and look into the file. I don't know if it's in a file or a database or whatever. All I know is this service, like an object actually, provides a very specific contract which says, here's the things you can do with me, and so long as this contract is satisfied, you're good. You can then change that thing from in-memory file to Postgres or to Redis or whatever. The test will not break. Like, there has to be some kind of side effect which you can test as an expected side effect of your test. Does that answer the question? Okay. Yeah. Perfect question. Okay, so the question was, what happens when the user service guys change the contract and don't tell us about it? And we don't change our test, we think everything works, and we deploy and it breaks. So that's where consumer-driven contracts come in. And we don't have those yet. We know we would like to have them, and we're working towards it. And so if you don't know, consumer-driven contracts actually solves the same problem. It says, okay, the contract you're testing against, is it the same contract which is used in the test of the user service itself, right? So are you testing against the same contract, or have they migrated away from each other? And tools like Pact allow you to do this. They even allow you to version contracts and would say, okay, the version of campaign service you're deploying relies on version 10 of user service contract, and user service currently in production is in version 11, so that's not going to fly. Roll back the deployment or something like that. So you can do all of these stuff, and it's very exciting. And yeah, if you don't have this automated checking, then, well, it's not really a big deal to communicate with your other team members or members from another team, especially if what you're doing is changing the external API. So it's not every day that you change this API. Every time you do, you should be careful. If you don't have automated checks that check contracts between services, you just have to communicate the change. There's no other silver bullet. Yeah. Well, the test client itself does not know anything about the schema, and that's an implementation detail of the service. If the service needs to migrate the schema, well, that's like,
About like migration, if you have a lot of data, you may not want to migrate and just have backwards compatibility,
yeah.
some kind of fixers or delete or whatever.
Yes, you might want to have backwards compatibility, yes. I mean,
And how do you test for that? Like, do I support the old schema still?
would I support the old database schema? Well, whatever, like, the point of supporting old database schema is that probably there's some kind of old version of the client which relies on the old schema. So there's an API, like backwards compatible API, which uses the old schema, which I can test, and I can have those tests and the new tests with the new schema. And like in a very specific case, I would need to look into it to see how exactly to test it. I could, like, the schema migration itself and whether we test it or not has never been a problem so far. Maybe I haven't stepped on it yet. So yeah, I don't know if that's a good answer. Just never been a problem really. Yeah, can I move to more slides because I have some more of them. I want to go through them, and then afterwards we can just talk. Okay, so one example of such a test would be like that. Very stripped down. I removed all the unnecessary details. So fetch strategy. A precondition in a Spock framework, which is a testing framework for Groovy, is I do a request of posting to API strategies with this data, and when I do a request to get that same strategy, I expect a certain response. So I can expect status code, any headers, and response body to be a JSON in a certain format and so on. So if you are going to write these kinds of tests, it's very important to not be bogged down by syntax noise, especially if you're testing JSON. So it's important to use a dynamic language. I'm reinforcing this point because it has like direct mappings to, or at least it looks like JSON, right? So Clojure, Groovy, whatever, JavaScript. And the nice part about it is I can even change the implementation language of the system under test itself. The test would not break in any way. And if you want to check what kind of messages were sent out, it's the same kind of story. Okay, I'm moving a little faster because I don't have much time left. The way we start those tests is we're using Docker Compose. We're saying Docker Compose up, which boots up the system under test and dependencies, which are mock dependencies. We run Gradle. It's a build tool, acceptance test task, and then we bring it all down. So this is the Docker Compose file we use. There's our campaign service and the database dependency and the message queue dependency and wiremock dependency, which is responsible for all of the interactions with other services. And this little dot right here, when we say build dot, if you don't know Docker Compose, what it does, it builds a Docker image out of this Docker file. It's a very simple file, just a jar, which exposes a single port and uses OpenJDK, the base image. That's it. There are ways to speed it up, but I don't have time to go into it. So, pros and cons. The most high-level benefits of this kind of approach is that you have a high-level spec of your system under test. And this spec has nothing to do with implementation details. It tests the things which really matter, which if they break, they actually will break production, like the contract of communication between services and integration to the database. It also captures what I just said. It serves as a contract between services, right? So whenever you say, I expect in this test that this service be called with such parameters, that's a contract. It's something you can send to the other team and say, okay, will you handle these kind of messages? Also, you can refactor inside how much you want, and you can also change programming language. It will not break the test. Now, are there any drawbacks to this approach? Well, of course, this is a great talk by Michael Fellers, It's called The Deep Synergy Between Testability and Good Design. You should look it up, by the way. And he talks about pain a lot. So he says, we as programmers have become numb to internal pain of internal bad design decisions. And so when we experience the pain of trying to write tests, unit tests, isolated tests, they force us to improve the design, because otherwise it will be just pain till the end of times. And I agree, pain is useful sometimes, and without the pain of internal design struggle, like these kinds of process level tests don't cause that pain. Another problem is, well, the big ball of mud problem, which you have heard probably if you were at Adam's talk today in the garage. Has anyone read the actual paper of Big Ball of Mud? Okay, nobody, wow. I have read it as a preparation for this talk. And the important thing is, it's not just a rant about the sad state of the industry. It tries to look positively into, okay, so many systems are this big ball of mud. There must be some good reason behind it. And there's actually a good reason, because if you have a big ball of mud which doesn't have the proper abstractions in your code yet, if you are in this early stage of startup development or something, you may not know what the proper abstraction is. So you are free to mangle and shape it any way you like. And you are not bogged down by mock-heavy unit tests to do that. So in this stage, having proper process-level tests, but no mock-level unit tests, it kind of makes sense. It allows you to make rapid changes inside of the code and still have the safety net outside of the code, until you know better. When you know better, you find the better abstractions and you write the isolated unit tests. And in a microservice world, this would be little balls of mud. So if you enforce the external contracts of the services, you will have nice communication decoupled. Everything inside is encapsulated, and it's a little ball of mud. But having lots of little balls of mud is much better than having one huge ball of mud. I can tell you that. I've worked on both, and this is better. That's the worst case scenario, right? So if you only concentrate on the external contract between services and these high-level tests, then you will get this. It's still better than big ball of mud. Slow feedback is another problem. So yes, these tests are slower than unit tests. The system takes longer to boot up than a single class, of course. And as J. Brainsberger noted, if you use these tests as feedback for basic correctness, and I emphasize this, in place of micro tests, you're going to get in trouble. So there are cases, a lot of cases actually, when it makes no sense to test all of them from the system level. For example, some kind of algorithm, right? A parsing algorithm. You want to parse an IBAN, international bank account number. You're not going to write 20 system level or microservice level tests to test all the different ways in which you can parse an IBAN number. It makes no sense. It will just explode. It will be too slow and too cumbersome. So of course, we also write unit tests for that. And this is another great talk, which I recommend, some to do with what I said. It's called Boundaries by Gary Bernhardt. Yeah, just what I said. Integration testing is bad at testing lots of complex cases. So for that, yeah, we actually do write isolated tests. We don't start with them, or sometimes we do. And they are cool for these simple cases where you can test things like a function. The nice thing about it is, when you already have a coverage around the system boundary, which gives you a safety net, you can afford to refactor things into pure functions before writing tests for them, right? So you already know that everything kind of integrates together nicely, and you can say, okay, I want to test this part in isolation. Maybe it's scattered all over the place, so you can gather it under a single unit into a single pure function with no side effects and test it easily with a simple unit test. So that's the strategy we approach, and it works quite nicely. So yeah, those are good enough tests. They are not perfect. Good enough is not perfect by definition, but they kind of get the job done. And most of the time, they have a nice balance of the amount of effort you spend and the amount of safety you get back in terms of regression testing. Okay, I think I'm done, and I'm done with time, right? So, come to me with questions. We'll continue. Thank you.